So as we continue to look at figuring out what the monthly payment would be on a loan, let's look at another example. Let's look at question 4 and see if we can bring this one to life. So find a monthly payment needed to amortize the principal and interest for the fixed rate mortgage given below. So again, we're going to pay regular monthly payments. So remember, amortizing a principal means pay equal monthly payments until the principal is down to zero, until the future value, the final value is zero. So we're going to first do this using the table. This seems to be the easiest way. So you should have a table in your MyLab. So this says 10% for 25 years. So the number we pull off the table is this 9.08701. So let's see if we get that then. So 9.08701. And then what we do is we multiply by the principal per thousands. So, but per thousands means we actually have to move this over 3 places to the left. So that's actually going to be 224.25 thousands of dollars. So if we multiply these two numbers together, that should give us our monthly payment. So our regular monthly payment until the loan is paid off. So let me pause a moment and pull up my calculator. So using the table, we could just multiply these two numbers together and that'll tell us what our monthly payment is. So if I do this 9.08701, and then if I multiply that by, again, we have to change this to per thousands. So the decimal moves 3 places to the left. So 224.25. If I do that math, that should give us our monthly payment. So big house, big payment. Whoa. So $2,037.76 would be my regular monthly payment for 25 years at a rate of 10%. So that's pretty steep. So I do also want to see if we can do this using the formula, the TVM solver formula. So let me pause and see if I can pull that up. So we also can use the TVM solver on the graphing calculator. Remember, this is in your Unit 4 folder if you want this link to this calculator. So if I hit apps, it pulls me up to finance. The TVM solver is number 1. Hit enter again. So if we go through here and do the math, we have what, 25 years, and we have to pay 12 times a year. So if I multiply 12 times 25, well, that gives me, I have to make 300 payments to pay off the house. Remember, the interest rate has to be in percent, so 10% goes there. Our present value is the principal, the loan amount, so 224,250. This here we actually don't know at this point, so we'll clear that out. The future value is we want that to be down to zero. So when we make our last payment, we don't want to have any more payments left, so the value should be zero. The payments per year, we're making 12 payments per year, and the compounding per year is 12 times a year. So as we were saying, N is the number of times we make payments. So this is going to be this 12 times this 25. That's going to give us this 300 payments at a rate of interest, which is 10%. Again, our present value is the 224,250. This is the thing we don't know. This is what we're going to solve for. This was, again, future value would be down to zero. Payments per year, again, was 12. Compounds per year is 12. So it looks like we got the data entered correctly. So to find the payments, monthly payment, if you will, the regular monthly payment, So if we highlight where the zero is there, and there's a solve button on the calculator, it's in green. So hit the alpha button and then solve. Notice how again it does give me this $2,037.76. But notice how we want to count it as a positive, not a negative there. So you're, in my lab, it doesn't want that to be a negative value, but technically that's going out. So that's actually a debt in your view. But they just want to know the monthly payments, so they want the actual positive value there in that. Okay, so let's see what else we got here.